Hello again and welcome back. As you can see, it's snowed now, and we are now in the year 2018. Last year went by so fast. I had a whole bunch of things planned to do, but hardly ever got to them. But I have a whole bunch more plans for this year, and today I just wanted to get out and just get out. Today it turned out to be a really nice day. As you can see, there's snow all over the place, but the sun came out and the clouds kind of cleared. It's a nice, beautiful day to be outside. I had all kinds of plans for 2017, just didn't really have time to get to them. But we will eventually. Only got, like 3 videos out of the whole year uploaded, which is not very good for a great start. Yeah, 2017 just flew by. I didn't get very many videos uploaded, but on my first video I noticed I got like, 730 views? And I think that's pretty great. I never expected to get that many views on my first video. And I noticed I have some new subscribers, so thank you for joining. And today I just want to get out and explore out in the snow here. It's a beautiful day to do it. So today, just going to explore a little bit of this mountain here and just be outside in the snow. This mountain is not a very big mountain. It's actually kind of small. But when you're here, it looks very large, and this is just the one. This is like a little valley. It's kind of like a little cutaway right here. This is like a little valley, and the mountain actually stretches out that way. And then it kind of stretches out this way, and actually kind of extends over that way before ending. But the main mountain's on the other side of this ridge here. And it's not a very tall mountain. But there's something over here I want to show you. Right here is an old foundation of an old home. This was like an old homestead over here. So, the snow's got an ice layer, so it kind of crunches. There, so you see that? They got like little shelves, some kind of shelving. I almost wonder if that's where they maybe not. I was thinking maybe they put like beams across right there. That's where their fireplace was. I'll get a better angle on that. But right there, it's kind of buried in the snow. That's kind of like some kind of sink or something. They got a metal pipe that goes into there. And I'll show you in a minute, here soon, where the other end of that metal pipe is. But if we continue on over here, this is kind of like this must have been like their porch right here. It's all buried in the snow, but there you can see the fireplace a little bit right there. It makes you wonder. This home has to be at least over 100 years old. Over out there is the remains of an old barn, but there's hardly anything there. It's like just a big chunk of concrete, and that's about it. But I think the house must have burnt down because underneath all the snow down there is a whole bunch of burnt timbers. So somewhere around here they have like an old apple tree or a cherry tree. Actually, I think that's it right there on the other side of the this fir here. In the springtime, those bulb flowers still grow in the spring that they planted here. Yeah, I think this is their apple tree right here. And down there they have an old garbage dump. They picked a really beautiful setting, and it's up on a hill, which is good because down there that floods and it gets all becomes a big puddle, and it gets all full of mud. It's always a good idea to build your house up on a tall hill. Right down here is a really cool spot that we're about to head into. I'm glad I'm making all kinds of noise going in here, so if there's a big moose or something hanging out down here, he'll hear me and hopefully he'll run away. It's kind of eerie going down in here at first because it's kind of all concealed off and hidden out of sight. It'd be easier if I had snowshoes or some kind of skis. I could just skid right across all this. This is what I'm talking about. There's animals that head right down in here. So, and there's a reason why they head down in here, which you'll see in a moment. That's where I just came from, and you walk in through the cedar trees and it opens up. And this is a really cool spot, especially in the spring, because it's just full of green. This area is really green in the springtime. And it's really, really nice in here. And in the summertime, when it's really hot, this area stays pretty cool. It's really, really quiet in here. All I can mainly hear is just the snow and ice falling off the trees. It's almost eerie. So let's continue. Some running water right here, as you can see. It goes up, it's right up there. But this is a huge cliff right here of the mountain. It's a huge, big rocky cliff area here. We're gonna head up there and get a closer look. The snow's pretty deep through here too. So hopefully I can get up there without dying. Here I am walking through this deep snow, struggling when I could be walking through this. It's a natural pathway up. I got waterproof boots on, so it should be no problem. Okay, here we are. This is a natural spring right here. If you listen really carefully, you can actually hear the water gurgling up out of the crack in the earth here. Remember that pipe I told you to remember at the homestead? I don't know if you can see it. See it right there? Right there. That is how they got their water, from this spring right here. This is a natural spring that rises up from the aquifer, and it rises up through the fractured rock and comes out right here and then flows on down. I don't know if you can hear that. So this is where they got their water. And there's that giant cliff I was telling you about. Well, in case you're wondering, some of you are wondering how cold the water is, it's not warm. It's not a hot spring. It's not a warm spring. It's just a spring that rises from the aquifer. And the water in the aquifer is above freezing. The actual water temperature in the aquifer is around 41 degrees. So when it comes up, it's not frozen, and it actually stays like this all winter long. It never freezes, and that's why it runs downstream. And of course it freezes at the bottom, but here it is. It's a big cliff area. Right in there. It goes way over there, and it goes way up there, and all the way down that way. And this is the bedrock right here. This rock is nice. It's another metamorphic rock. If you remember from my first video, the very first one, I mentioned about the metamorphic core complex system, how that formed, detachment faulting, and the different rocks. In my first video, I was probably about 10 to 15 miles in the mountains way over there out of sight. There's too many trees. And this mountain over here actually stands alone. It is all by itself, and I'm not quite sure for the reason why this mountain is all by itself. It's a standalone mountain, and usually mountains that stand by themselves are usually volcanic in origin, but this mountain is not volcanic. It is made up of metamorphic rock, and on the other side of the mountain it's actually made up of an intrusive igneous rock. So, not quite sure why this mountain is by itself. It's obvious that it was some kind of erosion force, like glaciers. There were glaciers a couple miles to the north from here. So it could have been over millions of years, the glacier activity and erosion separated this mountain from the main mountains over there and made it all by itself, all by its lonesome. And if you remember the detachment fault I told you guys about in that first video, we are actually pretty close to it. We are less than a mile away from that detachment fault. And the fault is actually down over that way, less than a mile. On the other side of these trees, it clears out, and there's a big valley, a big trench, if you will. And way over there, a few miles that way, are some sedimentary mountain ranges, the Rocky Mountains. They're over there. And over that way are the Metamorphic Mountains, and they are separated by a big trench, and in that trench is the fault line. And this mountain here is actually the closest mountain to the fault. So this bedrock here, this is really close to the fault line. And actually, on this side of the mountain, on the top of it, it actually slopes down like that. And actually, part of the mountain, the east side of the mountain, is actually the footwall of the fault line. But of course the fault is buried a few hundred feet underneath glacial and flood deposit sediments. But at one time, that side of the mountain was the footwall, which the fault was sliding down. And I could go on forever explaining everything, but this rock, of course, is gneiss. It's the highest grade of metamorphic rock. And actually this gneiss, remember, metamorphic rock is rock that it changed form, so it used to be a different kind of rock. Now in the case of the metamorphic gneiss over there, that used to be sedimentary rock, but in this case, this actually used to be a granite. So at one time there was magma. It came up, it crystallized, turned into granite, but due to extreme heat and pressure, because it was still deep down in the earth, it slowly changed into gneiss, and they call granite that changes into gneiss, instead of just calling it gneiss, you could just call it gneiss, but the other term for it is orthogneiss, because it used to be granite, then it turned into a metamorphic rock. So this is technically orthogneiss. Hope you got that. Now this orthogneiss, this gneiss here, has been myelinited, if you remember me talking about that in the first video, from the intense shearing force from the fault line moving due to ductile deformation, which you can see. I'll zoom in right here. You see that bend right here in the rock? And right here? And right there? See how it's all bent and twisted? That is ductile deformation. And to get ductile deformation, the rock has to be buried down where temperatures are high enough and pressures are high enough where the rock actually acts more like a plastic. So it doesn't break, it just kind of bends and flows as it moves, as the fault is shearing. So I'll try to visualize that. So ductile deformation, like I said, it's like a plastic. So as the fault's moving down, this would be like the footwall, this is the hanging wall. So as it's going down and sliding, at the point, the crack of the fault, that instead of that being break, everything around it in about a 4 about 4 kilometers worth of rock was actually just bending and just twisting and flowing without breaking, causing ductile deformation. Now if the rock was closer to the surface, it would be colder, not under intense pressure. So then, instead of flowing like plastic, the rock would just break and form a fracture. And that's more of your common fault there. And you can see all the results from the ductile deformation. You can see how the rock bent right here as it was getting squished down. So this bottom piece here, as you can see, because the fault dips down at this direction, so the top portion is moving this way, and the bottom portion is moving that way. So as it, the two directions are moving two opposite directions, it bends the rock like that, and you get this kind of a flow. The top portion is trying to go this way, and the bottom's going that way, and that is ductile deformation. Now the ductileness from here is, like I said, is 4 kilometers thick. So where the actual main faulting would be is technically would be way up there, which is mainly eroded away now. And like I said, the footwall of the mountain is actually over that way. So this is kind of the deeper section that would be mainly kind of being pulled up and out of the way, and the top section would be being pulled down, if you got that there. Now when this rock was underground, being sheared and pulled apart, there were tons of hot fluids running through these rocks and the fractures. So any fracture that formed from a breakage would be filled with minerals, forming veins, like this quartz vein right there. I'll try to zoom in. You see it right there? Right in there, it's kind of covered in the moss. So that would have been a fracture that got opened up, and then hot water and geothermal fluids would have rushed into that crack, and then the silica and the water would slowly start forming quartz crystals, and then eventually the whole vein just sealed off the fracture. And here's a close-up of that quartz vein. See, that's the quartz right here. It flows up and way over there that way. So this was a giant fracture that opened up during an earthquake. So the earthquake, the fault moved and fractured, and hot water filled in the fracture. So this was an earthquake event, most likely, that caused this fracture to form. Here's a really close look. If you look here, you can actually see, I don't know if you guys can, right here is actually quartz right here that's been deformed and bent due to the ductile. So this fracture actually happened when it was still deep underground. And I don't know if you can see this, but I'll try to zoom in. Right in here, there's some orange in here. Right there, there's like orange color, so it's like iron. So, as these hot fluids were coming up from the earth, any metals, such as gold, could have been pulled up with them, and then as it cools and crystallizes, the gold can deposit within these quartz veins along here. So, see right here, there's more quartz. Another quartz vein here. Big fracture zone right here, apparently. I'm not going to go any higher than this because it gets really icy and steep. But this is a frozen waterfall right here. There is a spring way up there out of sight, way up on the mountain. It flows down kind of like a little mini creek, and it overtops the cliff here, and it actually runs down out of sight on the opposite side of this ridge here, and kind of flows down this way, down that way. But in the wintertime it freezes over, so it kind of forms an ice dam, and then the water just flows over the side, making this waterfall. And in the springtime, this thing can, depending on how much snowfall there is in the year, this thing can get roaring with lots of water, and I might actually try to come back in the springtime and show you guys that, if I get the time. Yeah. So this mountain was uplifted by the extensional faulting. And this mountain's part of the core complex as well, but like I said, it just kind of stands by itself. and the fault is out that way, which you can't see, but maybe later when the snow melts I'll go up and explore the footwall. There's actually something pretty interesting up there that I'll have to show. But like I said, the detachment fault is actually down in the valley, and the interesting thing is, in 2015, now, it was in 2015 that this fault actually reawakened and gave us a couple of good shakes. It was like 2 or 3 good shakes from the fault, and a few months later it gave us another one. But the fault has been producing earthquakes it produced another earthquake about a week ago, but it has settled down some. But the fault is now considered active. So we'll have to see what it does in the future. So geologic activity is returning to the area, it seems. So we'll see what that does. There was actually an earthquake about a week ago. It was a 1.7. It was small. No one really noticed it. But I happen to have a seismograph, and I have detected a few really, really small microquakes that are so small that distant seismographs that are like used by like the U.S. Geologic Survey, they're so small that they're not detected by their stations because of how far away they are, and they're only detected by mine because mine the earthquake happens to happen right below or really, really close by to my seismograph station. If any of you are interested in getting your own seismograph, just leave a comment if you're interested in that. And if I get enough comments, I might even make a video to show you guys how you can get your own seismic station and start monitoring your own earthquakes. Well, it's time for me to head back, and that'll probably do it for today. This is my first video of 2018, and I got a lot of plans for this year. Now, there probably won't be too many videos for me right now because it's winter. In the wintertime, there's no chance of me really finding any gold, so I can't do any of that stuff, but we'll see what we do. I got plans, of course, for this summer. For the upcoming videos, we'll do some more prospecting, and hopefully we'll get back to that creek that I showed in my first video. In the future, I'll make some educational videos as well. If any of you are interested in having your own seismograph, just comment below and let me know. And if I get enough comments, then I may make a future video and show you how you can get your own seismic station and how you can start monitoring your own earthquakes. I hope you liked today's video, and if you haven't seen my first video, I'll probably leave a link in the description. So I'll see you all next time.